Hi everyone, it's Mara Schaefer. Today I'm going to be explaining this problem you see right here. It's from the ACS exam, so I thought it would be good to go over for me and hopefully for whoever is watching this. So the question is, what is the pH of a 0.20 molar solution of sodium benzoate? The Ka of benzoic acid is 6.5 times 10 to the negative 5. So the first thing you're going to do, write out the reaction. We're going to leave out Na because it's kind of spectating, so we're just going to write the benzoate part. So C6H5COO minus plus H2O yields benzoic acid plus OH minus. So the problem tells you that you have 0.20 molar of sodium benzoate, so you're going to put 0.20 right here, and water doesn't really matter, and the benzoic acid we don't know, so it's going to be 0, and OH minus we don't know. So now we're just going to do 0.20 minus X, and then we're going to skip water, and here we're going to have X because we don't know how much we have, and X again because we don't know how much we have. Next, we're going to go down here, and we're going to use Kw equals Ka times Kb. And we're going to use that because this problem, as you can tell, is basic. And the problem, and it gives you the Ka, which is for acidic, of benzoic acid. So we need to solve for the Kb of benzoic acid. So we have 1 times 10 to the negative 14 is Kw, and then we're just going to divide that by the Ka given, 6.5 times 10 to the negative 5, and we get 1.54 times 10 to the negative 10. So that's the Kb we're going to be using to solve for the concentrations of these two right here. So now we're going to move right here to this part right here, and we're going to put what we just solved for, 1.54 times 10 to the negative 10. The Kb is equal to the concentrations of the reactants over the products, and we don't include water in this, so it's going to be X, the concentration of X times concentration of X over the concentration of 0.20 minus X, and that simplified is going to give you X squared over 0.20, and we just put 0.20 because if it's raised to the power something less than negative 5, so like negative 5, negative 6, negative 7, and so on, it's not really going to make much of a difference. So in order to not make it really complicated and use the quadratic formula, we're just going to disregard this. So now it's going to leave you with that. We're going to multiply 0.20, so this cancels out, and then 0.20 by this side, and that gives you 3.08 times 10 to the negative 11 equals X squared. You're going to take the square root to find X, and that gives you 5.5 times 10 to the negative 6 molar, and that's equal to the concentration of OH minus. So that X is equal to this and this, but we're looking for OH minus, so we're going to use it for that. Next, we're going to do POH equals negative log of 5.5 times 10 to the negative 6 molar. And that gives you a POH of 5.26. But remember, the problem's asking for pH, so we're going to do pH plus POH equals 14. We know the POH is 5.26, so we just solve for that. So it's going to be 14 minus 5.26, and that gives you pH equals 8.74. Thanks for watching.